So today we are going to discuss about parallel and counter flow heat exchanger. So already we know, so there are three types of heat exchangers we are going to use based upon the direction of flow. So one is parallel flow, second one is counter flow, and then third one is cross flow heat exchanger. So here we are going to calculate the effectiveness for parallel flow heat exchanger as well as counter flow heat exchanger. So first of all, see the parts of this experimental setup. So here you can see this is the temperature indicator. So this is the temperature knob. So 1, 2, 3, 4. So these temperatures indicates. So T1 indicates hot water inlet temperature. T2 indicates hot water outlet temperature. Next T3 indicates cold water outlet and T4 indicates cold water inlet. Right? Now here you can see this is the rotometer used to find out the flow rate of the cold water. So now here you can see A, B, C, D walls. So based upon the position of the walls, we are going to set the parallel flow or counter flow direction. So suppose if it is parallel flow, then A wall as well as C wall should be open. Next, coming to the counter flow. So vice versa. So B and D wall should be open position and A and C should be in closed position. So first we are going to see the parallel flow heat exchanger. And then here you can see this is the pipe, right? Concentric pipe. So in this direction the hot water is flowing. So the red indicates the hot water and blue indicates the cold water. So here you can see the geyser. So we are going to supply hot water from the geyser, right? So we are going to heat the water in the geyser and we are going to supply hot water. So this is the hot water inlet. So this is the hot water inlet and here you can see this is the cold water inlet and this is the hot water exit and cold water exit because this is a parallel flow heat exchanger. Now we are going to turn on this main switch, right? So now we are going to turn on this main switch. As well as here you can see another switch which is related to the heater. So we are going to turn on the heater switch also. Now if you observe the temperature, so before after turning on the heater switch, now we need to adjust the flow rate. So for the cold water, we are going to set the flow rate as 1.5 liter per minute. So this is the cold water flow rate. So this is the cold water, and here we need to adjust the flow rate of hot water also. So from the geyser, so we are going to measure the flow rate. So that you can see at the back side of this experimental setup. Manually, we are going to calculate the flow rate of the hot water, right? So we are going to take the stopwatch as well as a measuring jar. So by using that, we are going to calculate the flow rate. So we need to set the same flow rate for that hot water also. So here we are going to set 1.5 for cold water as well as 1.5 liter per minute for hot water also. Now, so after this, we need to wait until the temperature reaches to the highest temperature in the geyser. So the geyser capacity is, so it will reach up to 66 degrees centigrade. So for this experimental setup, the geyser capacity will reach up to 66 degrees centigrade. So we need to wait until that. So after 66, if it reaches 66, what happens? So automatically the geyser cut off, means the temperature drops down. So here you can see the temperature is falling down because the geyser temperature has reached to 66. Now after some time again it will rise. So you can see. So after some time again the geyser temperature is going to rise. So now we need to wait until this temperature reaches to the highest one. So now you can see the temperatures are going to rise. So 49, next to 50. So now it reaches up to 65 or 66. So we need to wait until this temperature reaches to the 65 or 66. Then we need to note down the temperatures T1, T2, T3, T4. So now you can see, so the temperatures are rising. So it is 58, 59, then 60, so 62, 63, 64, So 65, right? So still it is rising. So now you can see it is going to start decreasing. Now you need to note down the remaining temperatures. So T1 is the hot water inlet. Next T2, right? Hot water outlet, it is 55. Next cold water T4. So what is the cold water inlet? 32. Cold water outlet, it is 37.5. So you can see the difference. So hot water inlet it is 60. Hot water outlet it is 55. So it is going to decrease, right? Cold water inlet it is 32 and cold water outlet it is 37. So the cold water temperature is increasing. So here you can see the heat transfer going to take place between the hot water as well as cold water. So after taking the temperatures, you can calculate the LMTD and you can use the effectiveness equation, right? So this is for parallel flow. Now the same we are going to repeat for the counter flow heat exchanger also. Now we are going to change the valve positions. Now we are going to turn off this A and we are going to open B, and we are going to close C and we are going to open D. So now the positions are reversible. So if you remember the counter flow heat exchanger, so the hot water inlet as well as the cold water inlet will be in opposite directions, right? So now again we are going to repeat the same procedure. We need to wait until the temperature reaches to the 65 or 66. Then we need to note down the temperatures T1, T2, T3, T4. So again here also we are going to maintain the same flow rate for cold water as well as hot water for the counter flow heat exchanger also. So this is how we are going to calculate the effectiveness for parallel flow as well as counter flow heat exchanger.